Today's topic is Scala from the trenches, which means that there are some employees from Czech companies that will talk to you about their experience with Scala, what it brought to them, what it took from them. And the speakers are Vlasta Menšík from Etnetera, who will be first. Then there will be a video from our meetup in Brno, where an employee of Good Data is talking about the same topic. Then there's a slight change of the program because Zbigněk Schleikert from Avast Software couldn't attend this meetup, so I will replace him. And I didn't have much time to prepare my presentation, so please be patient with me. And then in the end, Milan Raulim and Pavel Klupáček from Spinoko will talk about the same topic. And please pay attention because in the end there will be 2 questions, and you have the chance to win this nice T-shirt from TypeSafe. So, Vlasta Menšík.
Okay, so Scala from the trenches. Before we begin, I would like to describe or give you some idea what kind of projects we typically do at Etnetera, regardless of if we use Scala or not. So I've looked back on the projects that we do, and I've identified like 3 basic groups that most of projects fall into. I'm not saying that every project that we do falls into these categories, but most of them do. So our most typical project is some e-commerce site, typically an e-shop or betting site or classifieds. Here you can see the sites I'm talking about, and those are typically a large-scale website, heavily relying on performance and load. The second one is also typically a large website, but not focused on e-commerce, but on the content. So, for example, O2 and the governmental offices, like its Foreign Office and the Ministry of Agriculture, and more sites like that. And the third typical project is some backend web application, which is usually not publicly accessible, so it's not focused typically much on performance, but on the functionalities. So that's the stuff we most typically do, and these are some tools we typically use to do those projects. So we're a Java company, or historically we were. So we use things from the large Java ecosystem, things like Java EE, servlets, JPA, you name it, or Spring. We typically don't use like the heavyweight application containers from Java EE, like WebSphere and JBoss, but because we do most of the projects are web-based, we typically use lightweight web servlet containers like Tomcat. And over the years, we've built our own tools and libraries that we use to build those projects. And the first of them is we have our own templating system. It's called TFS. We also have our own web framework that's called Tangle, and we also have our CMS that's called JNet Publish, and we are planning to release some of those tools as open source projects. At the beginning or last week, we launched the Twinstone website, where we plan to build a platform for publishing our open source projects and engage with the open source community. So those are the typical Java tools that we use, and now let's talk about Scala. As you can see, the kind of projects that we do are not some very specialized, I don't know, scientific or data science projects. It's a little bit it's not something you will come or you will see only in very few companies. It's like the very basic stuff. And I'm saying that because Scala is a general purpose language and you can use it basically on any projects you want. You don't have to find some special kind of Scala project for it. So let's talk about some of the Scala tools we use now. Here are the 5 most important. As you have seen, we are typically building websites. So right now we are using the Play framework, which is a web framework based on the MVC design pattern. It's very similar to, let's say, Spring MVC. So, but it's very nice or friendly to use. Also, with Play is built on Netty and Akka. So when you use Play, you have also Akka built in, and Akka is like the de facto standard implementation of the actor model in Scala, since the original actors that were implemented in the Scala standard library were deprecated. So basically, if you do something that needs concurrent processing and stuff like that, you will most likely use Akka for that. Also, we've been using the Scala test library, which is a great library for writing tests. So it's similar, let's say, to JUnit or some similar XUnit framework. It's, I think, very well designed and very well documented. I think it's one of the best documented libraries I've ever seen in Java or Scala. SBT is a build system or build tool, something similar to Gradle or Maven, but built natively in Scala. And most Scala projects use it. And for example, if you use Play, it has its own console that is built in SBT. So it's basically a necessity if you're using Play. But I think that, to me, SBT is again friendlier to use than, let's say, Maven, which is a lot of XML. I don't like XML very much. And on the IDE side, historically we've been using Eclipse for Java programming. So we stayed with Eclipse in Scala, and we're using Scala IDE. That's a plugin for Eclipse that brings Scala support. It is supported by TypeSafe. And here we come to our first part of the contest for the t-shirts. Does anyone know where does the name Akka come from? What is it? What is the original meaning? It is a real world thing. And okay, so which one was first? I think that.
So I could be more at Sweden. There are the hills, but
Yes, Aka is a mountain in Sweden. So I think that Mr. on the right, it's the size L. I don't think you write it. It would fit. Okay, let's move on to our next slide, and let me tell you about the projects that we are currently developing in Scala. The first project is an e-commerce website. It is not. It's still in development, so I can't talk specifically about like who's the client or what's the site name and what does it exactly do. But I hope that next year, when it is launched, we can talk more specifically about that. But it was our first commercial Scala project, and because it is the public website that will have to handle a big load of traffic, we're building it on the Plain framework, and we're using MongoDB as the data store with Redis for caching and session storage for the Plain framework. And it's not a huge project. Let's say the development will take like, let's say 3 months for a team of 2 Scala or 3 programmers. The second one is a backend application, so something that's not publicly available, and it is providing a REST API for a website or front end that is not built in Scala. And again, for this project, we've chosen Play. And this project or this application is much smaller in scale than the website. But the Play is again very, I would say, user-friendly. So it was very easy to get the application or the core of the application started up and built. So I think it brings a lot of efficiency to the development process. And the last project that we are currently developing falls into the last category from the first slide. It is a backend web application, so not a public website. Here we're also using Play with lessons learned from the previous projects, and it's basically mostly focused on the functionality, not the performance. So, and this one is using, I think, MySQL as a database, so it's not less exotic technologies than for us, at least, than the large website. So, and of course, last but not least, our TwinStone open source platform is the website is currently running on Play also, so you can try it out. So here I've prepared some pros and cons of or lessons from our Scala development. It's probably, I didn't say it, but we started using Scala about a year ago, so it's gathered from that time, and we're still not like done with the adoption of Scala. All the projects are still in development, and we don't have like the feedback from the period after the projects are deployed and maintained for some time. That's also important, but so far we have these experiences. The first most obvious thing that I have in the pros is that Scala is, in my eyes or in my experience, like far superior language to Java that we've been using before. It's much more friendly to use, and you can express things much more concisely, and you can do stuff you just couldn't do in Java. And this is not the talk about the benefits of Scala. We've done talk like that early this year, but this is the most obvious and the most beneficial thing that also influences all the other stuff. The second thing is, even if you leave Java behind as a language, you still have the Java platform and Java libraries and frameworks and the whole ecosystem available. You don't have to do everything from the scratch. You can use existing Java solutions. So without that, we wouldn't be able to use Scala. Also, as you have seen, we're heavily using the plain framework and Akka that are the part of the type-safe reactive platform, and it is now called. It used to be type-safe stack, then type-safe, I don't know, platform. Now it's type-safe reactive platform. It's basically a set of Scala technologies that have been adopted or that are now supported by TypeSafe. So it's Play, Akka, Slick, I think, and SBT also. So there is these technologies are now maintained and developed by TypeSafe. So there is a good chance they will be there next year and the year after that, and they will get better. And also, it's in the name of the platform. It's reactive. It's almost a buzzword now, but in Scala and especially in Play and Akka, all the APIs and the processing model is non-blocking by default, which is very beneficial for scalability and performance, and it's very easy to do things reactively using Play and Scala. And in Java you can do it too, but the default approach and the traditional Java technologies are typically blocking by default, and the threading is typically one request per thread in servlets and things like that. So the platform as a whole is built for scalability, and I think that's a good thing, especially when you think about deployments in clouds and adding nodes as your traffic grows. And last but not least, as I've said that the language is superior to Java, it's simply more fun to program in Scala than in Java. At least I think that our team of developers agrees on that. So your developers are more, at least I am more motivated to program in Scala than in Java, and like happy developer is more productive developer. But there are some negatives, and the biggest negative for us is the Scala tooling, especially the IDE. As I've said before, we are using the Scala IDE for Eclipse, and it's simply not as mature as the Eclipse for Java. It is getting better, and it is definitely usable. It's not, because if it wasn't, we wouldn't use it. But the support for Java in Eclipse is much better than in Scala. There are some things or some features are simply not there, like, I don't know, like some advanced refactoring and stuff like that. But there is also the alternative IDE. IntelliJ has, I think, better support for Scala than Eclipse right now. But like switching from Eclipse to IntelliJ is like a big step, and it's you have to learn the things you are used to do all over again. It's almost like the switching of languages, as from Java to Scala or Java to Python, like going from Eclipse to IntelliJ. So maybe if the Eclipse Scala support doesn't get better as quickly as we want to, we might consider switching to IntelliJ, but right now we're sticking with Eclipse. But if you're an IntelliJ user, you have, I think, advantage. And the second one is there are simply almost no Scala professional developers in Czech Republic. Like there are some, but it's hiring a like Scala expert is almost impossible. And it depends what kind of a company or what kind of projects you do. It may be a problem, or it may not be. Like for like large companies that like do huge projects and use people interchangeably and hire them in January and fire them in May, that might be a big problem for them. But we're not like that, and we typically hire young developers and work with them, and they stay with us for years. So there is I think, a viable alternative to hiring Scala experts. You can hire Java developers who are interesting and excited about Scala, and give them the opportunity to use Scala in their work. I think there are a lot of people that use Java at work, but use Scala for their hobby projects or personal stuff, or play with Scala at home. So I think there's a definite possibility for hiring those people, even in Czech Republic. Of course, if you're like international company, there are Scala professionals in mainly USA or United Kingdom, but I'm talking from the perspective of the Czech company. So those are the most obvious on like the negatives we've experienced. There may be some other things that we will learn in coming months and years, but as I've said again, we have not launched the projects yet, so we might find some things in the coming months after the launches. So these are the pros and cons, and I also have some recommendations if you want to start using Scala in your job. And these are, again, from the point of a Java developer, like transition to Scala. So the first thing, don't do everything at once. Like take small steps. Don't try to rewrite all your code base to Scala. Pick something small and go from there. At first, avoid the advanced Scala stuff, like for example the Scala Z library is especially for Java developers that are beginning to grasp the concept of functional programming, it might make your head explode. It's basically a Haskell in Scala. Also, the new experimental features like macros and stuff, I think, are not the ideal first thing to do when you're starting with Scala. And don't reinvent the wheel. As I said before, you have the whole Java ecosystem available, and you can use any Java technology that you want. You can use Spring, you can use, I don't know, Hibernate, you can use anything that you know from Java. So don't spend months like trying to find the native Scala implementation of some problem if there is a perfectly ready and useful Java library, because it's, I think, not worth it. And if you're working in a team, you should adopt some common coding style, because in Scala you can do one thing in 5 or 10 different ways, and it's not clear which one is wrong, which one is right. You basically have to decide and come together on some common approach that you will be using consistently in your code base. So if a new guy comes into the team, he doesn't have to learn that like Joe uses this and Mike uses this for the same thing. And also do code reviews. Like dedicate a time, like every week or every 2 weeks, or depends on your possibilities, to do team reviews where you like discuss the work you've done and the problems, and decide on the coding style. How should we do this? How should we do that? Because it really helps, like, to share the experience, and the learning is much, I think, faster if you do it as a group than as individuals. And of course, one of the impulses for using Scala at our company was last year, when was the first functional programming course at Coursera, given by Martin Odersky. Many people in our company took that course, and not all of them started using Scala the next day, but I think these courses are really well prepared, and I think they are a great introduction to Scala. And in November there is a advanced course that is focused on the reactive programming that will continue the first functional programming course. So that's that. And that's all I have prepared. So if you have any questions, now is the time.
Okay. How do you plan to deploy these applications?
Deploy?
Yeah, some cloud.
No. We could do that, but the first projects, the website will be running on a dedicated hardware in a hosting center. It needs to be high available, so there will be two nodes running in a hot swap, basically replicas. It's a Play framework application, so it's basically you basically just need a JVM or Java installed, and it's from Play you get a whole package with all the libraries, and you just run it. So.
Any more questions?
Well, I came late, so you have already said it, but when you decided, when you were choosing the web framework, did you compare Lift and Play? And why did you choose Play?
Yes. Well, I gave some thought on Lift. I think we had a presentation last year in Czech Scala Enthusiasts, not here, but at the old, or the old space in Web Hub. Because, for me, the big factor is that the Play is the part of the type-safe stack or platform. So it is there is some expectation that it will be like maintained and developed in the coming years, but that's like one more like organizational thing. And the second thing is for the website that we're building, I think that the MVC approach of Play is a better fit than Lift, because as far as I know, Lift is more like component based with a stateful state on the server. And we've been using stuff like Spring MVC, which I think we didn't have problems with that. We also use component-based web frameworks. For example, the Tangle, our internal framework, is component-based with state on the server. But for the website, I think that Play is a better fit. But I don't have like a real experience in Lift. Maybe some Lift users will prove me wrong that Lift is better. But so far, we picked Play, and I think we're happy with it. So that's that. Any more questions?
Okay, so now we'll play the video from the meetup in Brno.
Right, so frankly, I'm a bit worried about quality of this presentation because I was asked to do this in English just a minute ago, so please be very, very patient. First, I would like to say thank you to Karel and Tibor for organizing this session, and I'm really happy that I see even other faces than my usual colleagues from GoData. Because if there were just people from GoData here, this presentation wouldn't make any sense at all. So I will talk about Scala and GoData, but not only about it. So once again, let me very briefly introduce myself. My name is Jan Dudek, and I work as a team lead here in GoData of a team which uses Scala. If you would like to, you can contact me on this email or follow me on Twitter. And please be sure to visit our web pages, godata.com. And if you are looking for a new job, don't forget to check our careers page or just write an email to me or to Libor. Since Brno is small, you will probably find an easy way to contact somebody from GoData. So just before I will start talking about Scala and GoData, I would like to talk something more in general about motivation. The main question is, why would a company want to start using Scala at all? You're a big company, you have many Java developers, and I would like to switch and start something new. There are some things about Scala which are really great. Of course, Scala rocks, but that's something we all know because that's the reason why we are here. But there's something more. Scala, this is what I see, keeps at least me motivated to learn again. I'm a, let's say, Java senior, and it's a pretty complex Java enterprise stuff. I know what to do. I know which frameworks I should use. I know what should I do in Java and what not. And it's pretty cool. But when I started to learn and use Scala, I really had to learn something new once again, which was great, which was great, because Scala has broken my routine, my programming and architecting routine. I just had to do something new. It really made me improve my skills as a programmer, because I'm a pretty typical object-oriented programmer, so I had to learn this functional paradigm once again. And Scala is also a great HR tool, because when I see some curriculum vitae and the guy has Scala knowledge there, I was like, okay, this one should be good. And it's even better when he really proves during the interview that he knows Scala. That's even better. And on the other side, when a company is known for using Scala, it for some programmers, it should be the sign that they would like to join this company. So it works as great advertisement as well. And there are even more good things about using Scala in a company which has been using Java already. Because when you start using Scala, you don't have to throw away all your JVM-based infrastructure like builds, packaging, deploys, etc. away. Because Scala it's still nothing but a JVM-based language. And when you switch from Java to Scala, you don't have to start writing like idiomatic Scala code just from the beginning. When I started to learn Scala and write some code in it, it was just a Java code written in Scala. It was purely object-oriented. It was just Java and Scala. And then I learned some new thing, and now I'm able to write like more idiomatic Scala code, which means I can use more immutability, I can use more functional stuff, and so on. And more importantly, you don't have to switch entirely. You can say, okay, let's keep the old code in Java. It will eventually become a legacy code, and let's write just the new stuff in Scala. Or you can say, okay, let's use Java for things where it makes sense. Let's use Scala for other things, just in a right tool for a right job sense. However, there are even some things which are not that good about using Scala. The worst thing is Scala requires very strict self-control, because Scala gives you millions of ways how to shoot your both legs in the same time. Speaking about enterprise languages, in the 90s we had C++. C++ provided you everything. You could also shoot your both legs at the same time. Then came Java, and it wasn't like that all C++ programmers switched to Java because Java provided more language stuff. It was because Java actually provided less language stuff, which means that companies didn't have to hire just brilliant programmers. They were finally able to hire just average programmers, and they knew that they won't be able to break so many things in Java like they were used to in C++. Now we finished the circle, and we are okay, but Java it doesn't provide enough language stuff. We should use Scala because it's all. We have implicit casting, we have infix notation, we have operators, and if you don't have a strict self-control, you will start using all this stuff, and your code will be completely unreadable. So the other thing is that what I said already, the ecosystem in Java is stable. When you start with a project, you know what to use. You can use the open source path like Spring, or you can use the enterprise path like JEE and stuff like that. But that's it. However, in Scala, you still have to many frameworks and libraries are created every day, and you have to choose. You have to choose the right one. Sometimes there are some problems also with the interoperability of established Java frameworks. Let's say your team is already used to use Hibernate for persistency, and you don't want actually to learn new ORM framework. So you say, okay, let's use Hibernate in Scala. It works, but it doesn't work that good because all this metadata programming and annotations, and it looks a bit weird. So there are some problems with interoperability. And most importantly, if you want to use Scala in your company, you need a skilled senior guy. It's not that easy to find one. Hopefully, you will be the skilled guys in your companies. And you need this skilled senior so you can do code reviews and select right frameworks and so on. All right, so that's about motivation. Now something about good data. Well, JVM-based languages are a huge part of good data. It's not just JVM-based languages. Good data has always been a very multi-language environment. We use Perl for both legacy stuff and some new code. We use Erlang for synchronous middleware. We use JavaScript for our web client, and of course we use many JVM-based languages. Java, of course, is still the most used JVM language. We even use Groovy for some testing stuff in one team, and in the team I'm part of, we use Scala for some specific tasks. Scala is in its rise in the team. So where we use Scala? What I can say is my team does data integration, and we found several areas where Scala is very useful. It's very good tool for data processing heavy algorithms because it's mostly mapping, filtering, reducing, and that's the functional language of Scala is very good for. Do some data integration stuff. Just got one system, other system, and we need some data pump between these. And we use Scala also for team tooling, for tools we just use in our team. But there are also several areas we don't use Java and we don't want to. The data as a platform is accessible through REST API and JSON documents. And in Java, we are still fans of Spring MVC, and the same case as Hibernate. Using Scala for Java metaprogramming isn't that good, and the code just doesn't look right. So we still use Java for Spring MVC and for REST API. Sometimes we have to write libraries which are used company-wide, and we write them in Scala so everybody is able to read them and use them, because the interoperability from Scala to Java is, let's say, fine. You can use every code in Java in your Scala code, but you unfortunately can't use every Scala code in your Java code. So company-wide libraries are written in Java. And of course, sometimes we provide Java tools for our customers, open source tools like our extension for HTTP client, and we write them in Java so every customer can use it and read it. So, as for conclusion, Scala fits the languages makes very good data. We use it in a right tool for a right job, since there are areas where it helps us make very good code, and there are areas where we use the Java because it makes better sense to us. All right, that's it. Thank you. And got any questions?
What is the biggest disadvantage of Scala you've encountered so far?
The problem is once you start writing code in Java in your team, you have to hire people who can actually write in Java, write in Scala. So since we started to use Scala, now I have to hire guys with Scala knowledge. It's not that simple because there are not so many people here in Brno who are actually able to coordinate.
Like 20 here.
Yeah, there's like thousands of IT companies here.
What IDE do you use for editing the Scala code using data?
I use NetBeans and it sucks.
Is there actually any preferred IDE or are the plugins? So
Yeah, all the guys from the team I'm part of use IDEA. Maybe you can say more about it. I just use NetBeans.
That's the best part. Nobody installed SBT beta plugin or nightly build, and it's awesome. It works like a charm.
Do you use some frameworks in data? Some Scala frameworks? Well, I don't think so. We use some testing frameworks. Scala frameworks?
Okay. Certainly.
Yeah. Maybe Richard, our architect, can say more about it than me, but
We do use AK, asynchronous framework, which is Scala framework, but we use a really old version, I think 1.1.2, and it's really old. Newest version is I think 2.2, and they make really huge API changes during in each version. For example, they used to use their own implemented their own feature, and now they are switching to Scala feature, which breaks almost every other API. So it's pretty painful.
yeah, Scala is used for very minor stuff, minor part of the platform, and basically just a Scala code for data processing, Scala custom code. As I said, as for web development, we still use Spring MVC. Alright, that's it. So thank you for coming and happy coding.
let me start with what we do. Probably you know Avast is the most spread Windows antivirus. We give it for free, and of course the client itself is written in C++, but it also has a huge Java backend, which is mostly written in Java, but there are also parts written in Scala, and that's why I'm here and I can talk about it. And we have our own framework called Reactor, which is based on Netty. And we, as the databases, we are using mostly Cassandra or Postgres if it's relational, but mostly Cassandra. So that's what we do. How Scala got into Avast? There is an architect in my team, who is called Zbigniew Schleicher, who was supposed to be here, and he liked Scala, and he realized he doesn't like any dependency injection frameworks on the market, so he decided to write his own. It's called Syringe. You can find it on GitHub because it has been open source, and this framework is based on Scala traits because they allow you to compose your application from different so-called perspectives in this framework. And so that's the first project written in Scala in Avast. And then I came to Avast and I started convincing everybody that they should use Scala. And I'm sometimes successful, sometimes not, but usually people like it. Currently, most of the projects at Avast are configured using Syringe, which means they are in some way dependent on Scala. You could say that there would be no backend of Avast without Scala. But only some of the projects, for example, FileWrap, Streambase, or Software Updater, are entirely written in Scala. Most of the developers in my team are still using Java, but when I talk to them about Scala, usually after a few weeks they start to like it and they want to use it in the future more and more. So I suppose that's good thing. Let me tell you something about FileWrap, because this is the project I'm responsible for, and you can find some information, mostly marketing information, on this link. It's a service when a user of Avast clicks or executes a file, information about that file is sent to Avast, and a reputation of that file is sent back. Reputation is basically the number of times we have seen that file and the timestamp of the first encounter of that file. And this information helps the Avast antivirus to decide whether that file is bad or not. We get 4,000 requests per second on each server, and we have around 12 servers. So it's a very high performance application, and the upcoming version, which is not released yet, but it will be hopefully next month, is written entirely in Scala. Some people say that Scala is slow, or it's slower than Java, but I don't think so. When I compare it to the Java version, which is running right now, it has the same performance. Maybe when you think in microseconds, it's a little bit slower, but in the end, it's all about blocking on the database, so you don't care about microseconds spent in some for loop in Scala or whatever. So it has the same performance. It has much less code, which I consider a very good thing. You don't have to maintain so much code. And what I probably like the most, I was able to create my own control structures. For example, for measuring the request time or throttling the throughput. So in the end, it's very easy to write the logic, because it's all wrapped in these things like measuring time or throughput. Let me maybe give you an example. So my method looks like this. So it's not important. The details are not important, but in the end, all the methods that are handling the requests need some kind of throttling or measuring time. And so I put these things in methods in my own control structures, and I use them like this. It's very similar to what the Blade framework is providing in its action methods. What tools are we using? As the IDE, we are using the IntelliJ IDEA. Some of the developers are using Eclipse, but most of them are switching to IDEA because the support of Scala is much better. And Vlasta said it's quite difficult to switch. In my opinion, it's not that difficult. I think like 1 day, maybe 2, and you can work in IDEA. It's perfect.
It's perfect.
As the build tool, we are using Maven. We haven't really tried MPT or Gradle because Maven is working for us. The only problem we have with Maven is when we need to recompile our applications for different versions of Scala. And that's quite problematic to do in Maven, to have it automatic. Which is connected to the disadvantages of Scala. I think the biggest disadvantage of Scala is the binary incompatibility. When you have a library in Scala 2.9 and you want to use it in Scala 2.10, you can't. You have to recompile it. And that's the biggest problem I see in Scala. And we have encountered that in our libraries because most of our projects are in Scala 2.9. And now when I want to use 2.10, I would need to force everybody to recompile. And that's not that easy. The other disadvantage is, I think, hiring. It's quite tough to hire a good Java developer, and I think it's impossible to hire a good Scala developer. But that does not mean you cannot hire. As Vlasta said, you can hire a good Java developer, and he can learn Scala quite easily. The only problem is, if you're in a fast development team like at Avast, it's quite difficult to do your job and learn proper Scala at the same time. But let me go to the advantages of Scala as I see them. For example, static typing. Java is also, of course, Java is statically typed, but Scala gives you much more powerful constructs, and it can give you kind of a safety net around you, so you don't do something bad. You don't have to write so much code. When I have to switch to Java now, I'm amazed how much code I need to write to do some simple things. And I think if you try Scala, you will never want to go back to Java again. Immutability, that's a very, very important thing. Backend projects at Avast are very concurrent. So we deal with a lot of threads, and you know that you can do bad things with memory. So it's good to have all your structures immutable, so you don't have to worry about that. Scala gives you case classes which are immutable, and they are almost for free. So it really helps you with that. And flexible syntax. As I said before, you can create your own control structures, and that helps you to refactor repetitive code into some common methods you can use in all your projects, which is perfect. And in the future, I think the high-performance backends we are creating require new technologies. Right now we are using our own framework based on Netty, but in the future I think we should definitely look into the reactive programming bus, which is basically represented by the Akka project and the Spray project, which was just acquired by TypeSafe. And in the end, they are best served with Scala. So I see the future of our projects at these projects, hopefully. But I'm not the architect, so maybe this will not happen. Okay, that's the end of my talk. It was quite quick, I know, but I didn't have much time to prepare this. Do you have any questions? No? So there's another question in our contest, if you want to win the t-shirt. And the question is, how many requests does FileRamp handle per second?
4,000.
48.
Okay, who said 48?
48.
to asi postně má, někdo se tam hlásil tady. Okay, so now let me introduce Milan Rowling from Spinoco.
My name is Milan Rowling and this is my colleague Pavel Kupáček. We work at Spinoco. It's a small company. We are developing communication software and services. We are technologically advanced. We are trying to use the least technologies we can. We are supporting open source development. We cooperate with some known people from open source. We are committing in some projects like Scala Z streams or Scala Z. Our company has about 600 customers in Czech and Slovak Republic and some in Poland. We are a quite small team. We have about 5 developers and we are bringing advantages of Scala and especially functional programming to our clients and customers. Okay, let's start. Scala, why not Scala Z? We heard that Scala Z is hard to learn, but I think it's not that hard. Other types to guide you. This motto, you can use it. If you will follow this, it's really easy to write anything in Scala Z. Because the compiler is really friend of yours, will notice anything wrong and will not let you do nothing bad, because everything must be must be connected through types. So you can check code, and if it doesn't compile, it's wrong. And if it's compiled, there's a big chance that it will run without any error. Scala Z, our code, so we use it. It's really great. You can have shorter code, less of syntactic sugar. Type annotation is heavily used in our code right now. Imagine the situation, we have ID, and this ID is type, it has some properties, doesn't matter, but we want to our different classes and different things to have ID, but we need some way how to distinguish these things and ID of every single thing you have. You can imagine you have a customer, and this customer has some products. So we want every single customer to have its own unique ID, and you have your product to have its own unique ID too. So there are 2 IDs, they are same, it's the same data type, but you need to distinguish them. And you can do this by type annotation. The syntax is very easy, you write just the ID, add and the name of the type, and we create the type that is ID, add and the name of the type, and Scala Z and the compiler will help you find errors if you will try to assign customer's ID into the product ID field. Monad. I don't want to talk much about Monad here, but it's going through Scala Z really heavy. It allows you to do all the operations on almost everything, and it's really useful. Next is task. Task, it's like a better future. You have futures in Scala and you have tasks in Scala Z. Task will help you control the runtime of everything, because when you create future, it will run instantly. But when you create task, it will not run. It will wait for you when you want it to run. You can flat map 2 tasks, many tasks, and you can create a final task, and then you will run it. Next is streams. Because iteratives are too hard to understand. I don't know anyone who understands Czech. Maybe you guys understand. I don't know. But it's really hard to learn them. It's really hard to understand them. And actors, they are like any two unit. They are not composable, and they are especially not type safe, which is really the biggest disadvantage of AK and actors. Streams, you can imagine this as a data. Everything is data. There are no functions, there is only data, and some of those data can transform other data. So they are like functions, but you have no stack. There is almost no stack because everything is in a heap, because it's all data. There is also disadvantage because you don't have stack trace, and it's sometimes very hard to find some errors. How do we use streams? We use them to connect to WebSocket, to push events to the web. We see those things like WebSocket or MongoDB as externalities to our software. We program everything in a functional style, so you need to handle those externalities. And streams are really great for this because you can pack these externalities into something called channel, and then you have full control over it, and it will not cause anything wrong in other part of code than in channel, and you can handle this. Publish subscribe model, like AK you can use AK in a publish and subscribe model, but you can also use streams like this. You can publish into one topic stream, and you can subscribe your streams to this topic, and then instantly everything you will publish to this topic, all those streams will react to this message. Testing, almost biggest part of our code is testing. If we start writing a new feature or anything new, first we write tests. We write the tests, and then we write production code which can suit this test. We use test 2, use it in functional tests, to do functional tests. And so it's also great that you can generate your documentation from those tests. Scala check. We use this for the huge tests. When you need some random data, randomly generated data, you can write them in Scala check, and then you can run about 1,000 tests. Selenium. Last 1 month, we need to test our GUI of web application. So we decided to use Selenium for this, and it's really great because you can start Chrome in Chrome Explorer, and you can test your application. You can see how the mouse is moving around the screen and clicking on buttons and filling in forms and so on. And you know that when you change something in the backend or in the front end, you will see if anything's wrong. You will see it here. What we've learned during the time we are using Scala, cake pattern isn't that good, like it seems on first look. Because you can very easily get Java lang null pointer exception. If you have many threads with many vowels, and those vowels are dependent each on others, there can be a situation when you need some of those vowels and they are not initialized, and you will get null pointer exception. So the only solution is to have everything lazy. So when you will need it, it will evaluate, and everything will work. AK actors. Okay, it's like Scala C without types. Because you can't use types in AK. There's no mechanism. Okay, there's something like channels in AK, but they are really limited. We are trying to avoid AK. Scala pickling. This is really young project. It's about serialization, and you need to serialize your data in some format like JSON. You need to send them over network and then deserialize them back. You can use pickling. It's based on macros, and it's not so good because macros are not that good supported in Scala. This uses the Scala Macro Paradise compiler, so you can write macros like simple strings with Q at the beginning. It's really complicated for our purpose because it's really a large project. It's trying to handle everything, and it's not what we are looking for. We are still looking for a better solution. For now, we are using Jackson serialization from Play framework. It's quite good for now. Okay, there are some references. If you have any questions, you can ask right now.
Oh, you said that you do everything functionally. You really mean it? No vars, no mutable structures, nothing, just the functional code.
Yes. Yes. No vars in our code. If there's a var, there's something wrong with the code.
Okay.
So we try to always avoid it. And therefore we use the free structures from the Scala Z to basically put everything on the heap, and then we use the Gaelic version. These are our friends to replace the vars.